Imagine a world without sound. The world would be so different. No music, no alarm clocks, no conversations. Now, let's turn up the volume. What do you hear now?
Yeah, we're in 45th. Why don't you walk back?
The concept of sound was first mentioned by Pythagoras, a Greek mathematician who noticed a correlation between the length of a string and the tone it produced. So sound is a vibration. In other words, it is a wave that travels through a medium such as a solid, liquid, or gas, thus making it perhaps audible to the recipient of these waves. One way of perceiving how sound waves pass through a medium can be by observing how the slinky vibrates and moves in a certain direction when I push it down the stairs. Notice the sound that is emitted from the slinky as it falls like a wave down the stairs. Since sound waves depend on its interaction with a certain medium, there cannot be sound in space, as space is a vacuum. This is not realistically what happens in space. Again, why don't we hear sound in space? Because there is no matter in space to transmit the sound waves created by the objects in space. Although, we can hear sound in a pressurized environment, such as a spaceship. The speed of sound depends primarily on the rigidity and density of the medium. The more rigid a material is in relation to its density, the faster a sound will travel. This is due to the strong intermolecular connections within the medium, so that any vibration through that medium is transmitted faster. So, the speed of sound in a solid is generally faster than for a liquid, and the speed of sound in a liquid is generally faster than in a gas. I'll just quickly mention too that temperature can also play a factor, particularly for gases, as the hotter material is, faster sound will travel through it as the material becomes less dense. The same would go for the effect of pressure on gas. Let's take a look now at how sound travels through different media. Again, the speed of sound varies depending on which medium it is transferred through. Scientists have measured that in the air at sea level at 15 degrees Celsius, sound travels at 340.29 meters per second. In water at 20 degrees Celsius, sound travels at 1,481 meters per second. In titanium at room temperature, sound travels at 6,010 meters per second, and at 12,860 meters per second in beryllium. As you travel yourself, enjoy the sounds of the world around you.